Today we're going to look at Q calculations, the means to determine the amount of energy transferred into or out of a material. The Q in the Q calculations represents the amount of heat transferred. We will use two basic equations to calculate the Q. These two equations should be somewhat familiar because you used them back in 8th grade physical science and again in earth science. Equation 1, Q equals mc delta T, and equation 2, Q equals m times capital H. Now you will have to carefully look at lab data, practice problems, test questions to look for major clues to differentiate between when you should use equation 1 versus equation 2. So for equation 1, Q equals mc delta T. One of the first clues to look for is that only one phase of matter is present. Your sample started off as all solid and remains as all solid. It was all liquid all the way through the transfer, or it remained completely in the gaseous phase through the transfer. The easier and bigger clue to also learn to recognize is that the sample has gone through a temperature change, delta T. Now, in order to make a successful Q calculation, you need to know what each letter in the equation, Q equals mc delta T, represents. And it also, you need to learn to recognize each one's unit. So Q represents the amount of heat. Q, the unit to represent a value, to represent Q, is when a number is assigned a capital letter J for joule. M stands for mass, so a quantity that you are really familiar with, and its unit most likely will be the gram, lowercase g. A newer variable for us is that lowercase c. It is the substance specific heat. The specific heat value is unique to a substance just like a density value, and the specific heat has a complicated, I always say it's a big ugly unit because it's a fraction of joules per gram degrees Celsius. And the last variable, the delta T, represents the temperature change, and because it is the difference between two temperature values, you will see it typically with a unit of degrees Celsius or possibly Kelvin. Quick note, you need to remember how to calculate a delta value. Delta looks like that triangle out in front of the capital T, but the delta value for science and math means change. You have calculated changes in math class, for instance, in determining the slope of a line, the change in y over the change in x. And remember, when you calculated the change in y, it's the final y value minus the initial y value, y2 minus y1. In science, we don't use 2 minus 1. We use the terms final minus initial instead. So for temperature, delta T is T final minus T initial. Or if we put it back in math terms, the second temperature minus the first temperature. So just make an extra note here that the delta T, the change, it could be a positive or negative value. On to equation 2. Q equals m times capital H. Two big things to look for to help you recognize when to use equation 2. First, you will have two phases of matter present. In your container or in the description of the word problem, you will have both solid and liquid present together, or a liquid and gaseous phases present together. Also, another big clue is that there is no delta T when we use equation 2. In fact, the temperature remains constant during this type of energy transfer. So a big clue or way a question may be written would be that a substance melts at 0 degrees Celsius. Notice the temperature is at a particular very specific temperature and not changing. Let's take a look at the variable in units for equation 2. Q, once again, represents the amount of heat, and any value for Q would be tagged with the unit of joule. M, once again, represents mass. A value representing the mass will be tagged with the unit of G for gram. So a newer variable here is the capital H. It is the heat of the phase change. And it, like specific heat, this is a unique value for a substance's particular phase change, and its unit is a fraction, joule per gram. Now, the H is specific to not only the substance, but the phase change the substance is going through. So we have two different types of H values per substance. If your substance is changing between the solid and liquid phase, solid to liquid or liquid to solid, we use the H of heat of fusion. Fusion is an older term for melting. So heat of fusion, pick out to use it if your descriptors are melting or freezing. If your sample is changing between the liquid and gaseous phase, liquid to gas, gas back to liquid, we will use the heat of vaporization value, and clues in the wording would be to boil or condense. Now this is a lot of new information, but the big picture is that you need to know how to use each of the Q equations, but there's lots of help in your reference table. On your table T, you will see all the Q equations plus the names of each lettered variable. Water is our most common substance that we calculate a Q value for. So water's specific heat, heat of fusion, and heat of vaporization are listed in a single table on the front page of your reference table, Table B. Take a look at both Table T and Table B. One last quick note, on the front of your reference table, besides Table B, there's also Table D, like in dog or delta, where it lists a quantity, its common variable, and its unit. So if you get stuck with what a joule, J, stands for, you can find it on Table J.